Good evening, Lawan. Let's begin the class. Right. Today we are actually to discuss about the unit 3. Right. We are going to start the unit 3, the chemical calculations. Right. Okay. To begin with, right. Let's discuss about the Avogadro's constant and the concept of mole. The concept of mole. Right. First of all, the Avogadro's constant. What this means, Lawan? What this Avogadro's constant mean? Right, in smaller ages, you had learned that Avogadro's constant, that is actually representing a number, no? Avogadro's constant representing a number. What is that number? The Avogadro's number. Okay. What is that? Avogadro's number is 6 point. What is that number? It is a 6.022 into 10 to the power 23. Right? This huge number is referred to as the Avogadro's number. Right? Avogadro's number. So with this, the Avogadro constant concept arise. Right. First of all, let's discuss about this number. What is the number? The Avogadro's number. Right. What is the definition, Lama? What is the definition of this Avogadro's number? Right. Let's discuss a bit about that thing as well. The definition is the Avogadro's number is the number of atoms in a sample of 12 grams of carbon 12 isotope. Right? If you are to count the number of atoms in 12 grams of carbon 12 isotope sample, then that count will be equal to this number. Right? That number is referred to as the Avogadro's number. Right? So what is the definition? Right? We can write a definition. The definition is number of atoms in exactly 12 grams of carbon 12 isotope, 12 carbon isotope sample. Is actually this number 6.022 into 20 to the power 23. Right? This number is referred to as, this huge number is referred to as the Avogadro's number, as the Avogadro's number. Avogadro's number. Right? This is the definition of the Avogadro's number, right? Number of atoms in exactly 12 grams of carbon 12 isotope is known as the Avogadro's number. Right? So when it comes to Avogadro's constant, right, a little difference is there. When it comes to Avogadro's constant, it is referred to as the 6.022 into 10^23 with some unit per mole. This is about that mole concept as well, right? If you have to think of the Avogadro's constant, it is written as 6.022 into 10 to the power 23 per mole. Right? Per mole. Right? Let's discuss about what this mole means. What these moles mean. The mole, the concept of mole. The mole is actually, right, this number of particles or this number of entities, this number of units in any consuming substance. This number of units in any consuming substance is referred to as a mole of that substance. A mole of that substance. That is the concept of mole. Right? This number of particles or units of any consuming substance is referred to as a mole of that substance. It is like dozens, couples, pairs. So if you are with two entities, two units, you will take it as a pair of shoes, 2 shoes, couple of, right, shoes, 2 shoes, right? Then dozen of pencils, 12 pencils. For the number 12, we call the dozen. For number 2, we call a pair. So you have 6. Let's say you have 6 books. So you can say half a dozen of books. Right? For the number 12, we call the dozen. For number 2, we call the pair. 2 units, 12 units, dozen. Like that, this amount of units, this amount of particles will be referred to as mole. Like, if you need an example, you can say, right? If you need an example, you can say, right? If you are with 6.022 into 10 to the power 23, right? Pencils. This amount of pencils, you can say you are with 1 mole of pencils. That is the simple idea. From any particle, for any species, if you are with this amount of units, then it is a mole of that substance. But if you are take 6.022 into 10 to the power 23 units of CO2 molecules, one can say you are with a mole of CO2 molecules. Like that. If you are with 6.022 into 10 to the power 23 of, right, oxygen atoms, one can say you are with a mole of oxygen atoms, right? So this number is referred to as a mole. This number of entities from any given species is referred to as a mole of that species. Right now, that is the concept of mole. From any species, if you are with Avogadros number of entities, right? If you are with Avogadros number of entities, that is referred to as a 1 mole of that species. 1 mole of that species, right? That is a simple idea about the moles, right? So let's go to the note. What it says in your note, right? At the page number 1, they are starting with the Avogadro's constant and the mole. It says number of atoms in exactly 12 grams of carbon 12 isotope, right? Is this amount, and this number is called as the Avogadro's number, and it is also referred to as 1 mole. Right? 1 mole, right? So at that space given, right, you can write this thing. Just write this thing at this space given, and even you can write like this, right? At the same space you can write 6.022 into 10 to the power 23. That number is referred to as 1 mole. Write that thing as well at that space. Just write this, right? Okay. So some examples are given. See, 1 mole of atoms. That means it is equal to 0.6022 into 10 to the power 23 of atoms. 1 mole of molecules means the Avogadro number of molecules. 1 mole of ions means Avogadro numbers of ions. Like that, right? Okay. The idea is clear. So if you are to refer like this. If one is saying that 5 moles of, I'll write it here, some more explanation. Right? If one to say, if one is saying like this, one is saying you are with 5 moles of, I'll write it in blue color. If one is saying that you are with 5 moles of pencils, then that is equal to 5 into moles. Moles means this number, 5 into moles, 6.022 into 23 of this amount of pencils. That is the idea, right? Simply that is the idea. This mole term, the mole thing is equal to this number. Like when you are referring to centi, the centi is equal to 10 to the power minus 2, no? Right? So that you can write the centimeter thing. If you are saying 5 centimeters, you will write it as 5 into, instead of c, you take 10 to the minus 2 meters, no? Like that, no? As c carries it into minus 2. Like that, nano is equal to 10 to the power minus 9, no? So if one is to say 12 nanometers, one can write that thing is equal to 12 into the n means 10 to the power minus 9 meters. Like that, no? So like that, 5 moles means 5 into 6 into 6.022 into 10 to the power 23 of pencils. Like that. So if someone is to say that you are with 47 moles of O2 molecules, then that means you are with 47 into, right, moles means 6.022 into 23 of O2 molecules. So like that, you should be able to convert the amount of moles given into the number of units, number of entities, right? Clear, no? 5 moles of pencils means 5 into this amount of pencils. 47 moles of O2 molecules means 47 into Avogadro number of O2 molecules, right? Like that, you should be able to convert the amount given in moles to the actual number, right now? Okay, so that is what that examples is, right? In your example at the bottom, you can write these two examples as well. For 5 moles of pencils means 5 into Avogadro number of pencils. 41 moles of O2 molecules means 47 into Avogadro number of O2 molecules. Got the idea? Right? Okay, we'll do a little example. We do a little calculation, right? So actually these are some stuff lama what we have learned, what you have learned in your O levels, right? In your O levels, we have done these things, right? I'm just refreshing what you have learned in your small ages, right? Before starting the theories at A levels, right? Let's revise some of the simple stuff learned in your O levels, right? That is what I am doing here, right? So let's copy some examples actually which are appearing at your tute, right? There's a question at the tute, right? It says the question number 1 at your tute, right? It says you have provided 2 moles of O2. You have provided 2 moles of O2. You have provided 2 moles of O2, right? This is provided. And they are asking you to calculate the number of O2 molecules first. Number of O2 molecules, right? Then they are asking you to calculate the number of oxygen atoms. Number of oxygen atoms. Then they ask you to calculate as in number 3 number of oxygen atoms. Here it was number of moles of oxygen atoms. Sorry, number of moles of oxygen atoms. Here number of oxygen atoms. But I'll write it here. It's better, no? Number of oxygen atoms. As the fourth question, they are asking number of moles of electrons. Number of moles of electrons. Finally, they are asking to find out about number of electrons. These are the questions appearing in your tutor, right? Let's solve these ones using the concepts you have learned so far. Even using the concepts at your O levels, right? Number of O2 molecules. That is the first question. Number of O2 molecules. So number of O2 molecules, right? Number of O2 molecules is 2 moles. Right? Number of O2 molecules is equal to 2 moles. 2 moles means as a number 2 into, right? Instead of mole, right? We are writing 6.022 into 20 to the power 23. So this is the number. As they are asking the number of O2 molecules, this is going to be the number. If they are asking you the number of moles, then you have to provide the answer in moles. If you are asking the number of moles, then you have to provide the answer in moles. If they are asking just the number of molecules, you have to provide the answer as just a number. Just the number of entities there. Right now? So 2 moles means 2 into this mole carries that idea, right? That mole carries that idea. What that idea? That mole is equal to unit is equal to 6.022 into the power 23, right? Okay. So instead of this mole, you can substitute this number. So this is the number of O2 molecules in 2 moles of O2. Right? Okay. Let's come up with the number of moles of O2 oxygen atoms. Number of moles of oxygen atoms in 2 moles of O2. Right? This is all regarding 2 moles of O2, right? That is your question asked in your tute, right? Okay. Number of moles of oxygen atoms. Right? If a question is asked like this, you have to first build up a relationship between the O2 and the oxygen. That means between the given data and the required data. First you have to build up a relationship. Right? After that only you could come up with a number related to oxygen. Because the given data is not about oxygen. Not about the alone oxygen. Given data is all about the O2. Right? So first you have to build up a relationship between the given data, the O2, and the required data, oxygen. Right? Let's build up that relationship. That will ultimately lead you to the answer. See? This is the relationship. So we know O2 with one O2, right? you have 2 of oxygen atoms. 1 O2 is equal to 2 of oxygen atoms. This is a relationship. This is a relationship. 1 O2 is equal to 2 of oxygen atoms. Right? So as you are with 2 moles of O2, as you have 2 moles of O2, then how many moles of oxygen should appear there? If one is with 1 O2, you are with 2 oxygens. If it's X amount of O2, you are with 2x of oxygen. Always oxygens will be twice that of the O2s. Oxygens will be twice that of the O2s. That means if you are with 2 moles, you should have 4 moles of oxygen. 4 moles of oxygen. Right now? The idea is clear. If with 1 mole of oxygen, if with 1 mole of O2, you are with 2 moles of oxygen. That means with 2 moles of O2, you are with 4 moles of oxygen. Right now? So the answer is 4 moles. Because the answer should be provided in terms of moles. They are asking about the number of moles of oxygen atoms. So it is 4 moles. The answer should be provided in moles. They are asking in moles, right? Okay. So next question. Number of oxygen atoms. Number of oxygen atoms. Number of oxygen atoms. See. So as you are with 4 moles of oxygen atoms, as they are asking the number, right? So it is going to be 4 into the mole term is equal to the Avogadros number, right? 4 into 6.022 into 10 to the power 2 into 3. There is a number of oxygen atoms. If they are asking number of oxygen atoms, you need to give the number. If they are asking you the number of moles, you have to provide it in terms of moles. Right now? That is the idea. Let's come to here. Number of moles of electrons. Number of moles of electrons. Again, now we have to build up a relationship between the electrons and the oxygen. You have to build up a relationship between the electrons and oxygen. A relationship between the given data and the required data. Given data and the required data. See, we know when it comes to O2, it is with how many electrons? One oxygen carries 80 electrons. You have such 2 oxygens. So 2 oxygens will carry 16 electrons. Right? So oxygen to electron ratio is 1 to 16. Oxygen to electron ratio is 1 to 16. One O2 carries 80 electrons, as one oxygen carries 80 electrons. That means 2 oxygens will carry 16 electrons. This is the relationship. First you have to build up this thing. Only if you have built up this thing correctly, you can come up with the correct answer. And we are looking for 2 moles of this stuff. 2 moles of O2. So that 2 moles of O2 should provide you how many moles of electrons? 1 mole of O2 will provide 16 moles of electrons. So 2 moles of O2 should provide 2 into 16 moles. That is going to be, right, 32 moles. 32 moles of electrons. They are asking in terms of moles, right? 32 moles of electrons. Got the idea? This thing, see, this one. Number of electrons. As you are with 32 moles, as a number, it should be 32 into 6.022 into the power 23. As a number they are asking, not as moles, as a number. So instead of mol, you can write this one, right? The Avogadros number. That is how we are supposed to solve this kind of a Simple question, right? Right. When they have asked you some asked you about some different species than the given species, then you have to build up a relationship between the given species and the wanted species, required species, right? Okay. Then only you are able to solve the question. See, in this case as well, they have provided some data for the O2 and they are asking some data for the oxygen, right? Oxygen. So that first you need to compute the relationship between the O2 and the oxygen, right? That will ultimately leads you the answer, right now. Okay, let's do the question number 2 as well. These are very simple stuff which you may have learned with the O level, right? Okay, let's do the second one, the question number 2. Right, this concept is still there only. This won't change. I'll keep that as it is. Right. Let's move towards the question number 2. First, write the things they are asking. The question number 2. Right. Question number 2 is about 3 moles of calcium chloride. In 3 moles of calcium chloride, right? They are asking the questions. They are asking you to find out these things. First, they are asking you to find out number of CaCl2 moles. Number of CaCl2 molecules. Secondly, they are asking you to find out the number of Ca2 plus ions. Number of Ca2 plus ions. Third stuff is about number of Cl minus ions. Fourth is on number of moles of Ca2 plus ions. Number of moles of Ca2 plus ions. I'll test. Then they will ask number of moles of Cl minus ions. And finally, it is about number of moles of total ions. Right? These are the questions they are asking. Right? These are the questions they are asking. Right. Just try to come up with good answers. Right? Okay, first thing. Number of calcium 2 plus molecules. Right? So we are with 3 moles. So they are asking you to convert that thing into the number without moles, just the total entities, right? So 3 into, instead of mole, we can substitute that value, the Avogadros number, 10 to power 23. This is the number of CaCl2 molecules, right now. Okay, let's try to come up with this one. Number of calcium 2 plus ions. Now, two different things. Early it was the given data is also about calcium chloride and the asking data is also about the calcium chloride. So there is no thing to develop there. There is no relationship to develop there. But if they have given the calcium chloride as the data, and if they have asking you the calcium 2 plus ions, about the calcium 2 plus ions, so then you have to first come up with a relationship. First you have to build up the relationship between the calcium chloride and the Ca2 plus, between the given data and the required data. First build up that relationship, right? We can say the calcium chloride, when calcium chloride is there, it is actually a combination of calcium 2 plus ions and 2 of Cl minus ions. Right? Calcium chloride is a combination of calcium 2 plus ions and the 2 of Cl minus ions. In your small ages, you have learned that, no? Calcium 2 plus ions, that is how this is made, no? By exchanging the valencies, calcium 2 plus ions and the Cl minus ions. Cl minus. 1 is there, Cl minus. 2 means 2 plus and Cl minus. Right? So this is the relationship between the given data and the required data. Right? So this is the given data and this is the required data. First you have to build up a relationship between the given data and the required data. Then only you can solve the question. Right. You are starting with 3 moles of calcium chloride. That is the given data. 3 moles of calcium chloride. They are asking you how many number of calcium 2 plus is available. So 3 moles of calcium chloride means you are with 3 moles of calcium 2 plus. 3 moles of calcium chloride means you are with 3 moles of calcium 2 plus as well, because 1 to 1 ratio. 1 to 1 ratio. If 1 mole of calcium chloride is there, that means 1 mole of Ca2 plus will appear. 1 to 1 ratio. So if you are with 3 moles of calcium chloride, that means 3 moles of calcium 2 plus will appear. So amount of calcium 2 plus in moles is 3 moles, but they are asking it as a number, just as a number, not as moles, just as a number. So that you can say 3 into, instead of moles, you write the Avogadros number. So this is the amount of calcium 2 plus ions in 3 moles of calcium chloride. This is the amount of calcium 2 plus ions in 3 moles of calcium chloride. Right? Regarding 3 moles, we are supposed to come up with the answers, right? Okay. Clear now? Let's come up with this one. Let's come up with this one. Number of Cl minus ions. Right? First thing to do is, first we need to build up a relationship between the Cl minus, the wanted data, and the given data, calcium chloride. First we have to build up a relationship between the wanted data and the given data. Right? Let's build up that thing. So we know in calcium chloride, right? It is constructed by these two type of ions, calcium 2 plus ions and 2 of Cl minus ions. Right? That is how the calcium chloride is made. Calcium 2 plus ions and the 2 of Cl minus ions. 2 of Cl minus ions, right? Cl minus ions. We have two such Cl minus ions, right? Okay. So this is the relationship, right? First you need to build up the relationship. Without that, you can't think of calculating number of unknown species, right? So this value, calcium chloride's value is 3 moles. That is the given data. Then this guy's value is going to be 6 moles. It's like if 1 mole of calcium chloride gives you 2 moles of Cl minus, 1 mole of calcium chloride gives you 2 moles of Cl minus, then 3 moles of calcium chloride should give twice of that. So the calcium chloride amount is 2 into 3 moles is 6 moles. Right now? This is a 1 to 2 ratio. 1 mole of this thing will give you 2 moles. That means 3 moles of this thing will give you 3 into 2 amount of moles. So as they are asking about just the number, not in terms of moles, just the number they are asking, so that the mole thing should be substituted with Avogadros number. Right now? This is the answer. Clear? That is the answer for the question number 3. Let's copy this one. Let's copy this one. Again, they are asking you to find out some unknown, right? They have given data for the calcium chloride and they are asking for calcium 2 plus. So first you need to build a relationship between the calcium chloride and the calcium 2 plus, given data and the asking data. So one can say calcium chloride is equal to actually calcium 2 plus, 1 of calcium 2 plus plus 2 of Cl minus. This is a relationship. So first you need to build up that thing, right? That will lead you to the answer. So you have 3 moles of this stuff. That means as 1-to-1 ratio is there, this is also will give you 3 moles. That is the answer. As they are asking in terms of moles. In terms of moles. Right? What about this one? Number of moles of Cl minus science. Number of moles of Cl minus science. See how to solve that thing. How to solve that thing. First of all, you have to build up this relationship between the calcium chloride and the Cl minus. So it is going to be like this, right? Then we need to apply the numbers. With the given data, it is given as 3 moles and they are asking for this amount. So 1 mole gives you 2 moles. That means 3 moles will give you 2 into 3 moles, right? Twice of the calcium chloride amount. So it is going to be 6 moles. They are asking in terms of moles, so the answer is 6 moles. In terms of moles, no? They are asking the number, right? Okay. Let's copy this one. Number of moles of total ions. They are asking total ions. So first you have to build up a relationship between the total ions and the calcium 2 plus, which is the given data. Let's build up the relationship. It is calcium chloride total ions is giving you Ca2 plus and 2 of Cl minus, right? That means 1 calcium chloride gives you 3 moles of ions. 1 will give you 3 ions. You have 3 ions. So 1 to 3 ratio is there. 1 to 3 ratio is there, right? So as they are with 3 moles of this thing, how many moles of ions should be there? So with 1 calcium chloride, 3 ions are there. So with 1 mole of calcium chloride, 3 moles of ions are there. That means with 3 moles of calcium chloride, it should be 3 into 3 moles of ions. 1 to 3 ratio. So if this is with 1, this should be with 3. So it is going to be 9 moles of ions. They are asking in terms of moles, right? 9 moles of ions. 9 moles of total ions, right? Okay. So those are some simple calculations, right? Actually, these you may have done those things even in the O levels, right? Some very simple calculations involved in the concept of moles. Let's move to the next section, right? Let's move to the next section. As the next section, we are going to study about the molecular weight, the concept of molecular weight or the molar mass, the concept of molecular weight or the molar mass, right? Okay, that is our next section, right? Molar mass, molar mass, molecular weight or anything, right? Molar mass. Normally, this will be symbolized by capital M. Molar mass will be symbolized by capital M, right? Okay, what is the unit of this thing? Molar mass is actually represented by with the unit of G mole minus 1. Normally we go with this unit. That is the commonly used unit for the molecular weight. G mole minus 1 grams mole. Right. Okay, first we'll discuss about the definition. First we'll discuss about the definition of the molar mass. The definition of the molar mass. Right? The definition of the molar mass. What is the definition, Lamai? The definition is actually, definition says it is the mass of 1 mole of units or 1 mole of entities of a given substance. The molar mass is the total mass of 1 mole of entities of a given substance. Right? That is the right definition. I'll write it here. The mass of 1 mole. 1 mole means 1 mole of, that means 6.022 into 10 to the power 23 number of units the mass of 1 mole of, so that means I've got a number of units of a given substance, of a considering substance. Or considering species is referred to as its molar mass. That its molar mass. So actually name carries the meaning, Ramay. Huh? Name carries the meaning. Molar mass, the mass of a 1 mole. Molar mass, the mass of a 1 mole. The mass of a 1 mole. Molar mass. Right? So this is the molar mass. This is the concept of molar mass. Right? The mass of 1 mole of units of a considering substance is referred to as its molar mass. Right? That is the concept of molar mass. Right? See? If you want to know with a bit more explanation, right? I'll give you this kind of explanation. Right? Let's say you are with a pencil. You're with a pencil, right? And its mass is just you are with one pencil, right? And its mass is just 5 grams, just 5 grams, right? So if one asks about the molar mass of identical pencils, the molar mass of these pencils, if they have asked such a question, how to come up with that thing? Molar mass of these pencils means the mass of Avogadros number of pencils. Mass of Avogadros number of pencils. Right? Mass of Avogadro number of pencils. That is the molar mass. That mass will be 5 into Avogadro's number. Right? 5 into Avogadro's number. 5 grams into Avogadro's number. Right? Like this. 5 grams into Avogadro's number. Right? So this number, this value, 5 into Avogadro's number. These grams. This gram value is referred to as the molar mass of these species is referred to as the, this value is referred to as the molar mass of those species. Right now, that is a simple idea. That is a simple idea. Right? Mass of Avogadros number of particles of a constituent species is referred to as the molar mass. So this is the molar mass. So one can say it is 5 into 6.022 into 10 power minus 2 20 power 2 and 3 g mole minus 1. G mole minus 1. The grams in a mole. Grams in a mole. Per mole. Grams per mole. Grams per mole. Per mole. This amount of grams are there. Right? It comes benzenes. Right? That is a simple idea. Mass of a 1 mole of entities. Mass of a 1 mole of entities. Here you have 1 mole of entities, right? 1 mole of eats. Mass of 1 mole of eats is referred to as the molar mass or molar weight. Right? Okay? That is the idea. This is the molar mass. Normally the molar mass is represented in g mole minus 1 units. So one can say 5 into this amount in g mole minus 1 per mole. Per mole. No worries, right? Per mole. Right? Okay. That is how we are supposed to come up with the molar mass. The concept is clear now? Right. So let's see how to calculate the molar mass. How to calculate the molar mass if for some substance if the mass and the moles are given. Let's see how to calculate this molar mass. Right? Okay. Let's go through that. Calculating the molar mass. Right? When the mass are and number of moles are known. Right? That is our next topic. Right? So let's see. Calculating the molar mass. When the mass and moles are known. When the mass and moles are known. Right? This is about that. Right? So for this we may need the definition, or we may need an equation. So for the molar mass, even in your little ages, you may have learnt about the equation like this. The molar mass is equal to mass over moles. Mass given in grams, moles given in moles. Then you will come up with the unit g mole minus 1. G over moles means g mole minus 1 in the linear form. Right? This kind of equation you may have learnt in your small ages. Right? In your small ages, you may have learned this thing. Right? But actually in A levels, we are not trying to memorize the equations. We are not trying to memorize the equations in A levels. Right? We are not trying to memorize the equations. Right? Let's see Then how come to solve a problem without using the equations? Without using the equations, how we are supposed to solve a question when the mass and moles are given? How to come up with the molar weight or the molar mass? Let's discuss about that thing. See, I'll give you some idea here, right? So example 1. Example 1. Let's go to the note here, right? In note, you have this kind of example. It says you have sample x. You have sample x. You have sample x. This you have sample x. Sample x. And there you have it 98 grams and 2 moles. You have it 90 grams there and 2 moles. In your sample x, you have 98 grams of x and 2 moles of x, right? Let's write like this: 98 moles, 2 moles. These are two data given. In your sample x, you have 90 grams and 2 moles, right? Let's try to come up with the molar weight of x. The question is, what is the molar weight of x? That is the question. Molar weight of x, right? Let's try to solve this one. So, to come up with the molar weight, right, what you should know is just the unit of the molar weight. We are not supposed to use the equations here. Just knowing the unit will give you the final answer easily without memorizing the right equations. So you should find in this question you should find the g mole minus 1 value. That should be the goal. So as they are asking the molar weight of x to find out, your goal should be to find out the g mole minus 1 value for the x. As they are asking that molar weight to find out, molar weight comes with g mole minus 1. No? So what they are asking is actually the value with the g mole minus 1. What they are asking is the actually value with the g mole minus 1. Right? So then what we need to do? So actually what we need to do is, as the molecular weight, what we need to do is actually the value represented with g should be divided by the value represented with mole. That is how we are supposed to come up with the unit g mole minus 1. Right? Value represented with the units g should be divided by the value represented with the unit moles. Then we will come up with the g mole minus 1 value. This is how we are supposed to use the units. Without using the equations, just use the units to come up with the answer. Right? Values which is given with in terms of g should be divided by the value which given with the unit moles. So that the g mole minus 1 units comes. So that is the unit for the molar weight, molar mass. So that should be the answer. Right? So using the units. Right? Let's do the stuff. So value with the grams is actually 98, and the value with the units mole is actually 2. So the answer is 49. 49 g mole minus 1. So it's very easy to solve the questions with the use of units. Then you no need to memorize the equations. What you just need to know or memorize is actually the unit of the molecular weight. All the guys, you know that unit of the molar weight is g mole minus 1. That is what you need to remember. Remembering the unit of the molar mass is enough to solve the question. No need of equations. Just handling the unit carefully. G mole minus 1 means it is actually the number appearing with G should be divided by this mole minus 1. This mole minus 1 should be divided by that mole minus 1 means mole is at the bottom, no? Mole minus 1. So show that it should be divided with the number appearing with the moles. Right? Now always these are very simple equations. What you may have to do is always multiplying all the divisions. Multiplications of the divisions you may have to do. Right? As mathematical operations. So in this case, it is going to be a division. The G value divided by the mole value will give you the G mole minus 1. Right now? So that is how we are supposed to solve this kind of a question. Right? Okay. Let's try to do another one with the same logics. Right? Let's try to do another question. Right? Let's copy the example number 2. Right? Let's do the example number 2. New page number 2. Right? There is example number 2 under the molar weight or molar mass. Right? There is a sample Y, and there you have 158 grams, and that 158 grams contain 1.5 moles. That is what it says. 1.5 moles of Y is there, and they are asking you to find out the molar weight of Y. Molar weight of Y. And what we know is the molar weight carrying the units G mole minus 1. Molar weight carrying the units G mole minus 1. So what we have to do? So that what we have to do is actually, as finding the molar weight of Y or molar mass of Y, what we have to do is actually divide in the value with G by the value with moles. Then you will get up with the G mole minus 1. Right? So the value with G is 158. Just divide that with value with moles, that is 1.5. So your number will be given as 105.33. So that is going to be your molar weight for the Y. Very simple. Handling the units carefully. Basically, there are two mathematical operations available, right? With these ones, you may have to divide the two properties, so you may have to multiply the two properties, right? That's all. Right? That is how we are supposed to come up with the molar weight when the grams and moles are known. Right now? Okay. So that is about the definition, right? Molar weight carrying is actually an amount of moles in one amount of grams. Molar mass is the amount of mass of 1 mole of substance. So what we have done was just to use that definition here, right? Okay, so let's discuss about few more ideas. This is about few more ideas about the molar mass. Basically, those ideas also you may have learned those things as well in your levels. We'll discuss few more. Right. Next, we are to discuss about the molar weight molar weight or molar mass of atoms. That is our next topic. Molar mass of atoms. Actually, the molar mass of atoms. The molar mass of atoms. Molar mass of atoms. The molar mass of atoms is actually equal to their average atomic weight. Average atomic weight will be equal to, right, numerical value of the average atomic mass. Atomic weight to one can say atomic mass, right? Equal to the average atomic mass, numerical value of that thing, right? If you need an example, right, this is the thing you should know, right? If you need an example, you know the oxygen's average atomic weight or atomic mass is equal to 16. Normally it comes with the number of protons and the neutrons at the nucleus for the most stable isotope. So that molar weight of oxygen is equal to 16 g mole minus 1. That is a simple idea. That is a simple idea, right? So let's come with another one. Hydrogen's average atomic weight or atomic mass is 1. The most stable isotope with the hydrogen, it is with 1. So that molar mass of hydrogen is equal to 1. Right? Normally in chemical calculation questions, the average atomic masses will be given. Oxygen 16, hydrogen 1, like that. Those will be given. So that finding out the molar weight of atoms is nothing there. Molar weight of atoms is nothing there. So it should be come with the g mole minus 1 unit, right? So finding out the molar weight of atoms is nothing, because these values will be provided. Average atomic masses will be provided, right? So that finding out the molar weight of atoms is nothing, right? Let's come with some interesting species. Let's come with the carbon 12. Average atomic mass is 12 actually with the carbon 12. So that molecular weight of carbon 12 is considered as 12 g mole minus 1. This is very interesting value here, right? So as a definition, we had said that 1 mole of particles of carbon 12 isotope is referred to as Avogadro number of carbon 12 atoms are referred to as 1 mole of carbon 12 atoms, right? And the mass of that thing is what? 12 grams. Actually, that is a definition. Of the mole. Definition of the Avogadros number or the mole. Right? What was the definition of the Avogadro number? What we have started up with. It said the number of atoms in exactly 12 grams of carbon 12 isotope. Number of atoms in exactly 12 grams of carbon 12 isotope is 1 mole. Is 1 mole. So that it says 1 mole of carbon 12 isotope atoms gives you 12 grams. Gives you 12 grams. That is what this says, right? 1 mole of carbon 12 isotope atoms gives you 12 grams. So the mass of 1 mole of carbon 12 isotopes is 12 grams. That is what we meant as the molar weight. Molar weight. Mass of 1 mole of considering particles. Mass of 1 mole of considering particles is the molar weight. Mass of 1 mole of carbon 12 will be 12 grams. So that is going to be its molar weight. The definitions of mole is also coming with this thing. And the Avogadro number even. Right now, that is how we are supposed to come up with the molar weight of atoms. It's very easy stuff because the average atomic masses of atoms will be given in normal day-to-day calculations. Right? So that coming up with the molar weight of atoms is nothing. Just what you need to do is just write in the unit G mole minus 1 after the average atomic mass. That will give you the molar weight of corresponding atoms. Right? Very easy, right? Let's discuss about finding out the molar weights of molecules. Molar weights of molecules. Or molar masses of molecules. Second step. Molar mass of molecules or compounds. Compounds. Compounds are the species, right, which are made by connecting more than one atom. Compounds are species, neutral species, which are made by connecting more than one atom, right? So let's discuss about the finding out the molar weight of them, right? The idea is this. So molar weight or the molar mass of a compound or a molecule, right, can be found out by taking summation of average atomic masses of each and every atom of your compound. So mole mass of a compound is equal to the summation of average atomic masses of all the constituent atoms of the compound. Right? This is how we are supposed to calculate the molar mass of a compound, right? Let's do some examples. And normally they will give you the average atomic weights, right? They will provide you the average atomic weight or average atomic masses. Let's say they have given you for the hydrogen, oxygen, and some other things as well, aluminium, as well as chlorine. Let's use these values. Right, to calculate the molar masses of these compounds, right? Let's come up with some examples, right? Let's find the molar weight of H2O, molar weight of H2O. So molar weight of H2O can be calculated by taking the summation of average atomic masses of all the constituent atoms in the compound. That means in H2O you have two hydrogens. So one hydrogen carrying number 1, such two hydrogens are there. Hydrogen means 1, such 2, 1 in 2, plus one oxygen is there. So oxygens carry number 60, right? Such one oxygen is there. So this number is going to be then 2 plus 16 is 18. So H2O's molar weight is 18 G mole minus 1. That's it, right? Let's come up with another example. AlCl3. See the molar weight of AlCl3. Molar weight of AlCl3. Right? So that means the AlCl3 is made by with a combination of 1 aluminium atom and 3 of fluorine atoms. So 1 aluminium atom carries 27 units for the molecular weight. 27 plus 1 chlorine carries 35.5, that into 3. That into 3. So that the number will be given as, right, 33.5 G mole minus 1 should be written ultimately. So molar mass of a compound is given by the summation of average atomic masses of all the constituent atoms of the compound. Right? You have 1 aluminium, that means 27, 3 chlorines, 35.5 into 3, because 1 chlorine carries 35.5, such 3 are there. Right? So like that, it is very easy to come up with the molar weight of a compound. Molar weight of a compound. Right? Simply what you need to do is just to add up the average atomic masses of all the constituent atoms in your compound. That will give you the molar weight of your compound. Right? So basically, these values, the molar weights of these compounds, are also referred to as the molecular weights. The molecular weights. Right? So as these are molecules now, H2O, the compounds are molecules now. So this is also, one can say, the H2O molecule now. Right? This is the AlCl3 molecule now. So that the molar weights we have calculated for the molecules can be also referred to as molecular weights. Molecular weights. So one can say the molar weight of an atom is referred to as the atomic weight or the atomic mass. Like that, molar weight of a molecule can be referred to as the molecular weight or the molecular mass. Simple as that, right? Mass of 1 mole of atoms is referred to as the molar weight of atoms, or one can say it as the atomic weight or atomic mass. Mass of 1 mole of molecules will be referred to as the molar weight of molecules. That can be written as molecular weight as well. Molecular weight or molecular mass, right? That is there at your ultimate statement at the page number 2. It says, so that the molecular weight of H2O can be referred to as 18 grams per mole, and the molecular weight of AlCl3 can be referred to as 133.5 grams per mole, right? Okay, so that is the concept of molecular weight, right? Okay, then let's do some example questions. regarding these things, right? Is clear now, right? Let's do some examples regarding stuff we have learned, and then you will get a clear idea what we have discussed so far, right? Okay, let's go to the page number 3. There you have some questions. Let's do those. Let's do the stuff, right? How to do these kind of calculations. Let's discuss. Right. So they are asking you to come up with masses. So your final answer, your final numerical value should come up with in terms of grams. In terms of grams. In terms of the units grams, unit G, your final answer should appear, right? So I'm going to use the method of comparing units to come up with the final answer, but I'm not going to consider any of the equations. We are not trying to memorize the equations. We are just solving the questions with the use of units, right? We are trying to come up with the correct unit. That is what we are doing, right? So mass is needed, so the number with G is needed, and the numbers provided are, what you see is there's a number provided, that is the mole number. The mole number is provided. Now in these kind of questions, the trick here is actually when you see this one, 4.0 moles of I2, right, you should see the hidden data appearing. You should see the hidden data appearing inside the chemical formula. You should see that. If you are able to see that, solving these kind of little problems are very easy, right? What is the hidden data in each and every chemical formula? In each and every chemical formula, there is a hidden data. What is that? That is the G mole minus 1 data. That is the G mole minus 1 data. The G mole minus 1 value. The G mole minus 1 value is hidden under each and every chemical formula. Right? Basically, you can come up with the G mole minus 1 value easily. So iodine, one of the iodine is 127. You have such two iodines. So the G mole minus 1 value here is 2 into 127. That is 254. 254. So actually, with this stuff, they have provided you two values. One value is the mole value. The other value is the G mole minus 1 value. Those two values are provided with the question, right? You should be able to see this. With each and every chemical formula, there is a hidden data. What is that? That is a G mole minus 1 value. This is G mole minus 1 value, right? So you have provided the mole value and the G mole minus 1 value, right? You have provided the mole value and the G mole minus 1 value, mole value and G mole minus 1 value. So you have to multiply or divide these guys to come up with the G value. Come up with the G value. That is your task. That is your task. You have to multiply or divide these guys to come up with the G value. That is the task here, right? Let's solve the problem, right? First of all, one can write, come up with G mole minus 1 value here. So I2 is G mole minus 1. Right? It is going to be 127 into 2. It is 254. It is okay. Now we are to come up with the mass of I2 here, right? So we need to come up with G term. Some value should come up with G term. So what we need to do? So we have to correctly, right, multiply or divide these two guys to come up with the G unit ultimately. So what we need to do? So actually, if you have to multiply these two guys, right? This mole and the mole minus 1 will cancel off and give you the genome. So what you need to do is just to multiply the mole value with g mole minus 1 value. Just multiply the mole value with the g mole minus 1 value. That will cancel off the mole things and give you the g value. So that is what we are supposed to do here. Right? As you need to come up with the answer in terms of g, as masses are needed. So you have to correctly handle the mole value and g mole minus 1 value. So basically, here you need to multiply the two values. Then the moles will cancel off to give you the g value. That is the mass. Right? That is how you are to handle the units to come up with the correct unit. Right? So the mole value is 4 moles. The mole value is 4 moles. Mole value is 4 moles. And the g mole minus 1 value is 254. So you will come up with the answer. So that answer will be 1060 grams. Right now, that is how we are supposed to complete this stuff. Let's do the same thing with this one as well. So here, the g mole minus 1 value is hidden. Always with the chemical formula, you have the g mole minus 1 value. First find that thing, and then you can think of these two units to come up with the unit g. Right? First of all, find this g mole minus 1 value. Right? For the Na2O is going to be 2 of sodiums are there. That means 23 into 2. Sodium carrier is 23. That into 2. Plus 1 oxygen is there. 16. Oxygen is 16, right? So that is going to be 62, no? 46, 62. Then to copy the mass of Na2O, just handle the g mole minus 1 value and the mole value correctly. So if you have to multiply these two guys, definitely, right, most thing will cancel off and the answer will come up with g. So just multiply the 2 moles, which is 2g mole minus 1. So the final answer will be 124 grams. Right now? Okay. Let's do the third question. Right? As we discussed earlier, this is g mole minus 1 value hidden here. Hidden under the chemical formula, always there's a g mole minus 1 value. Right? Let's come up with that thing first. That way may be very useful to find out the grams ultimately. The mole weight of MgCl2 is going to be then 1 magnesium carry 12 and 2 of fluorines. So 35.5 into 2. 2 of fluorines. Right? Then the number is ultimately, this is 71. Right? This is 71. And 12 is there, 83. Sorry, magnitude is 24, no, sorry for that. Magnitude is 24. So 24 and 71, it is 95. It's 95. That's a g mole minus 1 value, which was hidden under the chemical formula here. So now we are supposed to use this g mole minus 1 value and the mole value correctly to come up with grams. That is what they asked me. Masses. That grams term. Right? So we are supposed to come up with the mass of MgCl2. So that can be found by multiplying the moles value with the G mole minus 1 value. So it will give you the number 1.5 into 95. Let's calculate that thing. That is 142.5 grams. Right now? Right. Let's come up with the next one. Number 4. Right? Do the same. Do the same. So always the chemical formula, there is hidden data, which is the G mole minus 1. Right? Let's come up with that thing first of all. So molecular weight of sodium carbonate is equal to, there you have 2 of sodiums, so 2 into 3 for this one sodium, that into 2 because you have 2 of sodiums, and 1 carbon, this 12, and 3 of oxygens. 3 of oxygens. 1 oxygen carries 16, such 3. Right? If you add these things, it's 46 here, 58, and some 48. That is 106. Right? Now we can use these G mole minus 1 values and the moles values to come up with some G value. That is what we need. The mass. So the mass of sodium carbonate is equal to 0.03 moles into this value. So 3 into 106 is going to be 318, and you have 2 decimals, so that is 3.18. Right now? That is the final answer. Let's go to this one. The number 5, right? Let's do this stuff. Again, with this chemical formula, there's hidden data, which is the G mole minus 1 value. Right? G mole minus 1 value. Right? Let's come up with that thing first. So the molecular weight of copper sulfate dot 5H2O, that is equal to, you have 1 copper here, copper carries some 63.5, plus 1 sulfur and 4 oxygens. Sulfur carries 32, oxygen carries 16, and such 4 are needed. Such 4 are needed. So I'll write it here. 16 into 4 for the 4 oxygens. Right? Copper, sulfur 32, 4 oxygens. 16 into 4. And 5 of H2Os. This says 5 of H2Os, right? 5 of H2Os. This is not about a multiplication, right? Just copper sulfate connecting with 5 of H2Os. Right? It's like this, no? Because that thing is this, right? You have copper sulfate connected with 5 of H2Os. 5 hydrated H2 molecules. Like that. This is thing, right? Okay. So when you are supposed to come up with the molecular weight, what you need to do is just add in the stuff, add in the masses. Copper's mass, sulfur's mass, 4 of oxygen's mass, and 5 of H2O's masses. Right? So 1 H2O carry 18, 1 H2O carry 18. So 16 plus 2 is 18, no? 16 plus 2 is 18, no? 1 oxygen carry 18. So you have 5 of those. 5 into 18. It will be 90. It will be 90. Right? If you add these things up, it will give you 249.5 as a G mole minus 1 value. 249.5. Right, now we can use this value as well as this value to come up with the G value. Right, so the mass of copper sulfate 5:2. So that can be found by multiplying the moles value with the G mole minus 1 value. Then the moles will cancel off, as this is moles and this is the mole minus 1. The multiplication will cancel off those, and you will come up with a number with in terms of G. That is what we required, the mass. So 1 into 10 to the power minus 3 moles will be multiplied by 249.5 G mole minus 1. So the ultimate number is going to be 3 is there, 1, 2, 3. No? So one can write it as 0.2495 grams or 249.5 milligrams. Right. So that is the answer. Right. Okay. So that is about calculating the stuff or the calculating the masses. Then the moles data and the chemical formula is given. The chemical formula is given means they have given you the G mole minus 1 value. So here what we have done was just using the G mole minus 1 value and the mole value to ultimately come up with the G value. Right, that was the whole exercise what we have done just now. Right. Okay, I'm again telling you, right? Again and again I'm telling you, but there's hidden data in each and every chemical formula, right? That is the G mole minus 1 value. G mole minus 1 value. So let's copy that value, and that can be used to ultimately copy the answer, right? So G mole minus 1 value for the chlorine. So you have 35.5 into 2. 2 of fluorines are there into 2. Right? So that is going to be 71 G mole minus 1. Right. Let's think how to copy the answer now. As you know the G value and G mole minus 1 value. So here they are asking about number of moles. They are asking you to calculate the number of moles. Moles mean you need the answer, the final answer in mole unit. You need the final answer in mole unit. Now let's think of how to come up with the unit mole with the use of these two units. And you are provided G unit and G mole minus 1 unit. These are the two units you have provided. They have provided. And what you know actually. So you have to use, so you have to multiply or divide these two units to come up with the units mole. Come up with the units mole. Copy the units mole, right? Copy the units mole. You have to divide or multiply things appearing here. So what can you do? So as the ultimate unit, the unit mole, the G term is not appearing. The G terms are not appearing. The G terms are not appearing with the ultimate unit what you need. So that definitely this should be a division. Definitely this should be a division. You have to get rid of G. You have to get rid of G. Then only you can come up with just only a mole term as the final answer. First you need to get rid of G of these guys. So that definitely a division should be done. So you have two choices, whether to divide the G from G mole minus 1 or whether to divide the G mole minus 1 from G. The two availabilities are there, right? You can divide the G by G mole minus 1, that will also cancel G, as well as a division of G mole minus 1 with G. Both will ultimately cancel off the G. Cancel off the G. That is one requirement here. You just need to come up with in terms of moles the final answer. So, but think of moles as well. So if you are to do this kind of a stuff, if you divide the G mole minus 1 with G, if you divide the G mole minus 1 with G, G will cancel off, but not the mole minus 1, but then you will come up with the mole minus 1, but that is not required. That is not required here. So what we required is just moles, so that to come up with moles, the mole minus 1 term should appear at the bottom. To come up with moles, the mole minus 1 term should appear at the bottom. Then only it will come up as moles. So G mole minus 1 should be at the bottom there. G mole minus 1 should be at the bottom. At the top should have G. So that way you will be able to come up with moles as the final unit, right? So that is how we are thinking to come up with the answer in terms of moles, right? That is what we are looking for. That is what is required, right? Okay, so then what we need to do is just divide the number in terms of G with the number with the G mole minus 1. That will cancel off the G's and mole minus will come to up as moles, right? So we'll do that. So then the moles of Cl2 is then going to be dividing the G value with the G mole minus 1 value. So G's will cancel off and mole minus 1 comes top as moles. So it is going to be 2 moles. Right now? Okay. This one. Again, with the chemical formula, there's hidden data, which is that G mole minus 1 data. Let's copy that first of all. So molecular weight of sodium carbonate. Sodium carries 23. Such two are there. Right? Carbon carrying some 12 and 3 oxygens. So oxygen carrying some 16, that into 3 oxygens. Right? 3 oxygens. So you will end up with, you have 46 here, 12 here, 58, and some 48 there. So 106. This is G mole minus 1 value. Then we need to come up with the number of moles of sodium carbonate. So what we need to do here. So you have to get rid of G terms. And we need to come up with a mole term. Right? Not the mole minus 1, but a mole term. So that to get rid of G terms, you can divide the stuff. But to come up with mole term, you have to take the mole minus 1 to top, so that mole minus 1 should be written at the bottom. Then when it comes to top, it will come as moles. So the G value is 2.16 and the G mole minus 1 value is 106. So final answer will be 0.02. Right now? Okay. Let's copy it. This one. Again, I'm telling you, there is a hidden term here, G mole minus 1 with the chemical formula. Let's copy that. So molecular weight of MgCl2 is actually 1 magnesium is there, that means 24 plus 2 of chlorines, 35.5 into 2. That is going to be 95. Right? Then we are referring to the moles. Up with the term moles, we need to divide this thing with this. So 2.85, the value with grams should be divided with the value with g mole minus 1. So that will give you some value. For the 2 it is 0, for 20 it is 0, but for 285 it is 3 units, right? Right now, it's very easy to solve it, right? This one, again, with this you have the g mole minus 1 thing, right? The chemical formula g mole minus 1 is always there. So first copy that. Potassium carries some 39, such 2 atoms are there, and oxygen carries some 16, right? That means 39 into 78 and 16, 94. Then we need to copy the moles of K2O. There is going to be a division. This thing should be divided by this. Then only G's will cancel off and moles come to top. Mole minus 1 comes to top as moles. So that is 1.88 grams divided by 94 G mole minus 1. So ultimate answer is going to be 0.02 in terms of moles. Right now? Okay. Right. The final stuff. Right? The final stuff. So you have barium hydroxide. Again, I'm telling you, you have the G mole minus 1 value here. So first copy that. Molar weight of BaOH2. That is just 127, 137. 137 is there with the barium. And oxygen and hydrogen. Oxygen is 16, hydrogen is 1, that is 17, 17 into 2. Such 2 things are there. 17 into 2. Oxygen 16, hydrogen 1, it is 17. 17 into 2. 34. And this is 137, so 171. G mole minus 1 value is. Then copy the moles. To copy the moles, you need to divide the G value with G mole minus 1 value. Then only the moles value, moles comes to the top, right? So G value divided by G mole minus 1 value. It will give you the moles value. This is going to be 0.3. Right? That is your answer. Right? That is your answer. Okay. Let's come up with the next concept. Stoichiometry. Right. What this means? Actually, stoichiometry means here, actually, let's come up with like this. Here, with the stoichiometry, what we are referring to is, actually, we are discussing about the numerical relationship between the constituent chemicals in a balanced chemical reaction. that is what we are doing here, right? With the stoichiometry, what we are doing here is we are concerning on the numerical relationships between the components of a reaction. The numerical relationship between components of a reaction will be discussed with the concept stoichiometry, right? So in your note, stoichiometry is the measure of the quantitative relationship between the reactants and the products of a given chemical reaction. To achieve this, more concept is used. That is what your tute says, right? Okay. Simply, stoichiometry is giving you the numerical relationship between the chemical components of a chemical reaction, right? That is what meant by the stoichiometry, right? Okay, let's discuss about some example how the molar concept or mole concept is used. Our task now is to, let's assume our task now is to come up with the number of, come up with the grams of H2 if the amount of sodium is provided. See, sodium's grams are provided. Sodium's amount is provided as 92 grams. Sodium's amount is provided as 92 grams. And they are asking you to find out the mass of H2. That is your task. They are asking you to find out the mass of H2 by providing the mass of sodium. Let's see how to solve this kind of question. They have provided you the mass of sodium and they are asking you to come up with the mass of H2, right? See. So first of all, right, we should be able to identify the difference between this question, this problem, and the problems we have solved earlier. What is the difference there? What is the difference of this problem compared to the problems we have solved earlier? What is the basic difference you see? Earlier, they have given some data regarding some species and they have asked you some other data of the same species. Like at the first question, right? They may have provided some I2 is it 2 moles and they will ask you the mass of same I2. Mass of same I2 is asked. So data provided and the data asked, data provided and the data asked, both are for the same chemical species. They have given some data for the I2 and they have asked you the mass of I2. The data provided, the number of moles, and the data asked, the mass. Both are referring to the same chemical species. Earlier we had done such questions. Like they will provide you some, right, 71 grams of Cl2 and they will ask you the amount of moles of Cl2. So in this case, you clearly see data provided and the data asked, both are regarding the same chemical species. So that then it is very easy to solve. Very easy to solve, like in earlier cases. But here, the major difference is they have provided some data regarding sodium and they have asked you some data about the hydrogen. Two different species are involved. Known data is about sodium, but the asking data is about hydrogen. Then, with this kind of stuff, we need the use of stoichiometry to solve these kind of questions, right? Let's see how come the data for sodium thing will relate to the data of some hydrogen, right? See, The point is this, Lama. According to the balanced chemical reaction, we know when 2 moles of sodium is to react with 2 moles of HCl, we know 2 moles of NaCl and 1 mole of H2 will produce. 2 moles of NaCl and 1 mole of H2 will produce. That is what this balanced chemical reaction is. According to the balanced chemical reaction, if 2 moles of sodium is participated in the reaction, according to the balanced chemical reaction, 1 mole of H2 should produce. So that is what meant by the stoichiometry. 2 moles of sodium is related to 1 mole of H2. That is the stoichiometry. Right? 2 moles of sodium is related to 1 mole of H2. So that relationship can be used to solve this kind of a problem. So first of all, you should note that these values, the 2, 2, 2, 1, those values are referring to moles. Those are not about masses. This is not about 2 grams of sodium is related to 2 grams of HCl. That is not the case, right? That is not like that. It is all about 2 moles of sodium related to 2 moles of HCl, as well as 2 moles of NaCl and 1 mole of H2. So these values are all about carrying some data about moles. These values are carrying some data about moles, right? Okay. Right. So let's try to solve this one. So how to solve this thing? So definitely, other than the 92 grams data, another data is available, as they are giving you the chemical formula, the balanced chemical formula, balanced chemical reaction, right? What we know is if 2 moles of sodium is to react, 1 mole of H2 should produce. 2 to 1 ratio is there with the mole ratio. That is known, another known data. So the two data provided in this question is that 92 grams with the sodium and the mole ratio 2 to 1 with the sodium and hydrogen, right? Let's use this stuff to solve this kind of question, right? So always bridge between the sodium and hydrogen is provided by the moles. That is what it says. 2 moles of sodium related to 1 mole of hydrogen. Always the bridge between sodium and hydrogen is provided by moles. So that what we need to do, first convert this value into moles. Convert this value into moles. Then that value and the moles values of H2 will be related through the stoichiometry. Right? This value and that value is related through the stoichiometry, the mole ratio, which is 2 to 1. You can use that. If you know the number of moles of sodium, then you can come up with the number of moles of H2. That is 2 to 1. If there is X moles, you should have X over 2 moles of that thing. When you have 2 moles here, you have 1 mole of this thing. That means X moles here, X over 2 moles of H2, like that, right? So HMP is provided through the moles, right? It's very important. Bridge between the two chemical species are provided through moles. That is the most important stuff to grab from here. Then if you know the number of moles here, definitely you can come up with the mass. These stuff are done earlier with the earliest things. If you know the grams of one substance, you can come up with the moles of that substance. That is simple stuff we have learned with the last questions. If you know the number of moles, you should be able to convert it to mass of the same substance. That is normal stuff. So what we are learning now is this thing, right? The bridge between the two chemical species, which is provided by the stoichiometric numbers 2 to 1, right? Those numbers are referred to as stoichiometric numbers. Right, let's solve the question then. Let's solve the questions then, right? Solving the question. solving problem, right? Okay. Solving problem. Let's solve. So first of all, what we need to do? First of all, we need to calculate the number of moles of sodium, right? Moles of sodium. Moles of sodium. That can be calculated by dividing the G value with G mole minus 1 value. Divide the G value from G mole minus 1 value. That will give you the moles value. The G value of sodium is 92. That is provided. Grams of sodium is provided as 92. What is the G mole minus 1 value of sodium? Sodium carries 23, no? Carries 23. So 23. Right? That is the value appearing here, right? Sodium carrying 23. Right? So that moles of sodium is actually 4 moles. 4 moles. Right? After finding the moles of sodium, we can come up with the moles of hydrogen because those are related with 2 to 1 ratio. Right? As sodium to hydrogen are related with 2 to 1 ratio. Right? We can write the moles of H2 is equal to half the amount of moles of sodium. Got the idea? Half the amount of moles of sodium. If you have 2 moles here, only 1 mole of hydrogen will be there. 2 to 1 ratio. So if you have 4 moles there, right, half the number of moles should be here. That is going to be, right, 2 moles. Half the value. And now this value is referred to as stoichiometric ratio. This thing is referred to as the stoichiometric ratio. We'll discuss more about this thing. We'll discuss a bit more about this thing, right? And after that, we can come up with the mass of H2. Mass of H2. So you are with 2 moles. To come up with mass, you have to multiply the mole value with G mole minus 1 value. If you multiply the mole value with G mole minus 1 value, most thing will cancel off, give you the G value. So what is the G mole minus 1 value of H2? It is 2 grams. Hydrogen is 1. 1 into 2 is 2 grams. So the ultimate value is be 4 grams. 4 grams, right? So that is how you are supposed to solve the problem. Right? Ne? So actually, in these questions, the bridge will be provided by the stoichiometric ratio. The stoichiometric ratio. Right? The molar ratio. The bridge will be provided by that. So they have given you data of sodium and they have asked you some data of H2. The bridge between the sodium and hydrogen is provided by the molar ratio or the stoichiometric ratio. Right? Okay. That is how we are supposed to solve the question. First of all, sodium's data should be converted to the sodium's number of moles. Sodium's, whatever the data given with sodium should be converted to sodium's number of moles. Then that can be converted to the hydrogen's number of moles with the use of stoichiometric ratio. Numbers appear in there in the equation. Then you can convert that hydrogen's number of moles to whatever the value you need, right? Whatever the property you need, you can do so with the simple calculations what we have done earlier, right? Now, so this is the idea. This is the idea. Okay, so that is how we are supposed to solve this kind of question. Right now? Okay, you can write this thing in your note, the space given at the page number 4. This is space, right? You can complete the note here. Right. So I thought of discussing a bit more about this stoichiometry ratio, how to come up with the value of the other species when the mass of some other species is known. If the mass of one species is given, so the mass of other species can be found with the use of stoichiometry ratio, no? With the use of stoichiometry ratio, no? This thing, no? Right? Let's discuss how to use that thing, how to use that ratio. Let's do some bit more exercises to use this ratio. This is very important, nah? This is the most important stuff in this case, right? Converting the sodium's value to the hydrogen value is done through the bridge of moles, right? So this thing should be correctly done, right? In this case, it was easy because the 2-to-1 ratio is there. That means the half the value should appear there. It's very easy, no? Because the ratio is 2-to-1. What happens if the ratio is like 7-to-5? Ratio is like 3-to-8. If such kind of ratio is there, how to handle this stuff? Let's discuss a bit more about that thing. This is very important, huh? Let's discuss about handling such situations. Right? This is clear, no? Right. Let's come up with few more stuff about handling the stoichiometric ratio correctly. Stoichiometric ratio. Right. More examples. See, let's say you are with 3 of A producing 5 of B. 5 of B. Right? Let's assume they have provided that you are with 0.8 moles of this substance, and they are asking the number of moles of this one. Right? Now you need to use the stoichiometric ratio correctly, right? This example 1. Nah? Just try to use the stoichiometric ratio correctly, right? So moles of A is equal to 0.8. That is some provided data. Now we are going to use the stoichiometric ratio 3-to-5 to come up with the numbers of B. It can be easily used like this, Lama. It can be easily used like this. So actually 0.8 moles is actually representing 3 portions. 0.8 is representing 3 portions. We need such 5 portions. So if 3 moles are reacted, 5 moles will be produced now with this one. So if 3 portions are reacted, 5 portions will be produced now. If 3x is reacted, 5x will be produced now, like that now. If 3 portions are reacted with A, 5 portions will be produced with B. That is the idea, no? So 0.8 representing 3 portions. We need such 5 portions as B, right? So that means you can write like this. So 0.8 moles representing 3 portions. That means per 1 portion, the amount is 0.8 over 3. If you divide the 0.8 by 3, then you will get the value for 1 portion. we need such 5 portions. We need such 5 portions. Right? 0.8 over 3 means that is the value for one portion. We need such 5 portions. So this thing can be easily written as not like this. Just put this 3 under the 5. That is also the same, no? Under the 5. That is how we are supposed to come up with the number of moles of B. So we can simplify now. So 5 into 8 is just 0.8 is 4. 4 over 3 is just 1.33 moles. Right? Let's do another example. Let's come up with another example to get this idea clearly. Example number 2. Let's say you have 4 of P goes to 7 of Q. Right? And let's say you are with, right, 1 into 10 to the power minus 3 moles of this thing, and they are asking you how many moles of Q will be produced by this reaction. Right? Let's solve that thing. So the given data is about moles of P, which is equal to 1 into 2 minus 3, and to come up with the moles of Q, we need to use the stoichiometry ratio. How to come up with that? So 1 into 10 to the power minus 3 representing 4 portions. 1 into 10 to the power minus 3 representing 4 portions. So for one portion, it should be divided by 4. For one portion, it should be divided by 4. We need such 7 portions. We need such 7 portions as Q. We need such 7 portions as Q. Right? So the value is that. So it is going to be 7 over 4 means 1 point, right, 75 into 10 to the power minus 3. Got it right? Right? Let's discuss about another one, another situation. Right? Let's like this. 8 of X gives you, right, 3 of Y. Right? Let's say they have given you that they have produced with this reaction, they have produced 0.06 moles of Y, and they are asking you the value for X here. How many amount of X should react to produce this amount of Y? Let's say that is the question. So how to calculate the amount of moles of X here? So the given data, first write the given data. So moles of Y is 0.06 moles. Right? So you are supposed to come up with moles of X. Moles of X. So actually 0.06 is about 3 portions. 0.06 is about 3 portions. We need such 8 portions, right? It's about 0.06 is about 3 portions. So per one portion, it is 0.06 divided by 3. 0.06 divided by 3 is per one portion. So we need such 8 portions. We need such 8 portions. Right? Okay. So we'll copy the answer. Right? So it is like 48, yeah. So 0.16. right now. That is how you're supposed to use the stoichiometric ratio correctly. This thing, stoichiometric ratio correctly. It's very important to use this stoichiometric ratio correctly, right? If not, the total question will be wrong, right? Okay, got the idea? Right. Let's do an example question with the use of these knowledges, right? What you have gathered. Let's do the examples appearing at the page number 4. Right. So they have provided you the data, some data about NUH. They have provided you some data about NUH. And they are asking about H2O. They are asking about H2O. So definitely, stoichiometry should be used. The stoichiometry between the NUH and the H2O should be used. Right? 2 to 2 ratio should be used. Let's do the stuff. So first of all, what we need to do is you have to convert this grams into moles of NaOH. So always the bridge is provided by moles. First you need to convert the given data into moles of that species. First you need to convert the given data into moles of the same chemical species. Then you can convert that moles of that species to the moles of the required species. The moles of required species. Then you can convert that moles of the required species to the required data. Okay, right. Let's do the stuff. So first of all, I'm converting these grams into moles of NaOH, because only with the moles you can come up with a bridge. You can bridge thing to the H2O, right? Okay, so moles of sodium hydroxide. So moles of sodium hydroxide is going to be 120 grams are there, should be divided by molar weight of this thing, NaOH molar weight. So NaOH molar weight, right? NaOH molar weight, right? I'll write it here. NaOH molar weight. Sodium is 40, oxygen is 16. Sorry. Sodium is 23, oxygen is 16, hydrogen is 1. Thing is 40. Right? So 40 G mole minus 1, the value is 40. Right? Always this guy's molar weight should be used, right? NaOH. So it is going to be 3 moles. Let's use the stoichiometry to come up with the number of moles of H2. Moles of H2. Sorry, H2O. Sorry, H2O. This is what they're asking, right? Required data. What we need to do? So 3 moles are for 2 portions. 3 moles are for 2 portions. So per 1 portion, it should be divided by 2. Should be divided by 2. We need such 2 portions. We need such 2 portions. Like this. So the number of moles are going to be just 3 moles. Right now? So bridge is done. Then the mass of required data. Mass of H2O. This is our required data. So 3 moles are given. So you need to come up with a numerical value in terms of G. You need to come up with a numerical value in terms of G. Mass means G in grams. No? So what you need to do? So here under H2O, the G mole minus 1 value is hidden. There's hidden data under H2O. You need the G. You need the G. You know the moles. You know the moles. And this value is known. So use these two guys to come up with G. Use these two guys to come up with G. So basically, if you are to multiply the two guys, you will end up with G. So 3 moles should be multiplied with H2O's G mole minus 1 value, which is 18. H2O's G mole minus 1 value is 18. No? 1 and 16. 1 and 16. 18. So that you will come up with 54 grams as the answer. Right now? That is how we are supposed to do this kind of question. Right. Let's do this one. The same kind of calculation for the sodium sulfate. I'll use a different color for the sulfate situation. So the given data is about NaOH. Given data is about NaOH, and they are asking some data about the sodium sulfate. Given data is about the NaOH, and asking some data about the sodium sulfate. Right? So that we have to use the stoichiometry, right? So you to use the stoichiometry, first of all, we need to come up with the number of moles of the given species. Right? Okay. So we can write. So moles of NaOH that is found earlier. I'll take the same value as earlier, 3 moles. So you can convert that thing into the moles of sodium sulfate. That is the bridge between the two chemicals, right? So for that, what we need to do? There 3 moles representing 2 portions. 3 moles representing 2 portions. So we need to divide it by 2. 3 moles representing 2 portions. We need such 1 portion. So multiply by 1. So that value is going to be 1.5 moles. Sodium sulfate value is going to be 1.5 moles. Then we can copy the mass. Right? So mass is needed. That means G value is needed. So you know the mole value, and you know the G mole minus 1 value as well, because it is hidden under the chemical formula. Right? Let's copy the G mole minus 1 value as well. Then we can use these two guys to come up with the G value. So for the sodium sulfate, I write it. For sodium sulfate, for the G mole minus 1 value. So you have 22, 2 of 22s, that is 46, and sulfur is 32, and 4 oxygens, these are 48, 4 oxygens, so 64, 16 into 4 is 64, right? The total value is 10, 12 is 1 is there, 142. 142 is the G mole minus 1 value, right? So to come up with G, the G mole minus 1 value should multiply with mole value, so that most things will cancel off and we will ultimately end up with G. That is what we should do. So 1.5 moles will be multiplied by the G mole minus 1 value, which is 142. So that you will end up with some value, right? Like 230. Right? That is how we are supposed to solve this kind of question. Right now? Okay. Right. Done. Right. Then you have the question number 2 as well. Question number 2 is also there in your note. Right. Just do that one. Right. Do that at home. Right. I'll provide you the answers. Right. Just do the question number 2. Right. So that's all. That's all for today, right? We'll wind up at this stage, right? And next week we'll do the next session under the calculations, right? See you then. Goodbye then.